They're going to be talking about selection and use of FRP poles, and this is a case study directly from Hawaiian Electric. Garrett's been employed as a structural engineer at Hawaiian Electric Company for the last 8 years, working on substation and overhead transmission distribution projects. And Bob has sold poles for transmission distribution for 11 years, currently employed by Creative Protrusions as an outside sales rep. All right, thank you very much, Garrett. If you'd like to go ahead.
All right, thank you. Thanks for coming this morning. As our presentation is on the selection and use of FRP poles. It's a Hawaiian Electric Company case study. We're going to be referring to Hawaiian Electric Company as HECO from here on throughout the presentation. You may notice that we're dressed a little bit differently. We've been kind of casual, but this is actually pretty formal in Hawaii. I can go to anything except prom right here. Tucked in, I got, I don't have jeans, so we're pretty good right here. Oh wait, I need the pointer. Sorry. Okay, here we go. Okay. First off, the purpose of our case study here was to show that HECO engineering and construction typically resistant to change or implementation of new technologies. Engineering is typically resistant because nobody really likes to be the front runner and try out new things. There's always that fear of failure, things failing. Engineers are pretty conservative, especially structural. You don't like to see things fall down. Construction crews are line crews and things like that. They don't like new things. They like things that they're accustomed with. Things that they're very familiar. Safety is always a big concern. So anytime you bring something out, it's really got to be proven, and they got to feel really comfortable. So we want to, one of the purposes was to get them to work together and see if we could come up with some new technology here. And we also want to show a method that can be used to implement new technologies. Okay, let me give you a little bit of background here on HECO. Wood poles were first used in Hawaii when electricity was introduced in the 1880s. King Kalakaua, Hawaii was still a territory and not a state yet at that time, visited New York and met Thomas Edison. He was so impressed with electricity and thought it was such a great idea that he did what all kings would do. Came back to Hawaii, and of course he electrified his own palace. Hey, he's the king, right? And then he pushed that out onto the streets of Honolulu. Shortly thereafter, in October 13, 1891, HECO was incorporated. And FRP poles were first used in Hawaii in the 1957. FRP is fiber reinforced polymer, so we'll be referring to that. And in our case, typically now fiberglass. So when they were installed in 1957, they were put in kind of a test project. And in 1990s, in the early 90s, they were inspected again. So we went back to take a look to see what condition these poles were in. And what we found was that these poles had a damaged surface. On the exterior, the poles had deteriorated due to the UV, and the fiberglass cloth was exposed. The resin had deteriorated some. The poles were still found to be structurally sound though. They had survived 2 hurricanes during that time, one in 1982, one also in 1992, with a 70 to 80 mile per hour wind. So structurally, these poles were not deficient, just aesthetically. So they were replaced with wood poles just because people would just look at them and think something's wrong because they appear to be a bit fuzzy because the fibers are getting exposed. At HECO, prior to 2003, we used only 3 different types of poles. Probably similar to a lot of other utilities, wood probably being the most common, steel, and also wood was the primary material used for distribution, almost exclusively for our 12 kV and below poles. Sub-transmission, we use a lot of wood and some steel. And for 138 kV, which is our transmission level in Hawaii, they're used on our 8-story structures. Steel and concrete, we have limited pole applications. Typically, you only see our higher structural loads. In 2003, this is a while back, Every did a study. Every did a study for us, and they concluded that the average useful life of a wooden pole in Hawaii is limited to about 20 years. And of all our overhead-related maintenance resources, nearly 90% are utilized for the replacement of our wood poles. And going along with what Andy said the first day about how our infrastructure is aging, we're in the same situation at Hawaiian Electric, where we're a utility where we have an aging infrastructure, and 90% of our maintenance costs were towards the replacement of our wood poles in our system, which is extremely high. One of the big problems in Hawaii for our wood poles is foremost in termites. I'm not sure how widespread they are across the U.S., but in Hawaii it's a very big problem. So the pole life, that average life of 20 years, that's very dependent on where these poles are located. If they're in an area where termites are present, the pole life can be significantly shorter. Termites typically eat the untreated hardwood of the pole. So they're being eaten from the inside out. One of the problems with this is it's difficult to determine if your pole has damage. You can look at a wood pole and it'll look perfectly fine. You go up to check in and as it says right here, can hollow the wood pole to a 3/8 inch of a shell. And you know, a pole has strength still, similar to a steel pole, where if it has that shell, but down to 3/8 of an inch, I'm pretty sure you're not going to have too much strength for that. No matter what you try and convince anyone. As you can see here, this is one of those poles, you know, that they went out to inspect, and we have a test and treat program in place for wood poles, but that also goes towards the operations and maintenance budget. So you can see that all of these wood poles need to be inspected and treated and tested on a rotating cycle, and the only way that you can test these poles is to actually drill them. So we drill these poles, so you have to do destructive testing on these poles to determine how much shell thickness you have. In this pole right here, this is one of those 3/8 inch shell thickness poles, so this pole needs to be replaced immediately. The pen there is for scale and reference, so you can see it probably went right in. This is another shot of a pole that's been cut at about the 10-foot line. This pole has about 2.5 to 3.5 inches left of shell thickness. You can see what it looks like on the inside when termites do get into the pole. And although it looks like there's still material in there, that material that's in there is pretty much like paper. When you touch it, it'll just crumble. I mean, it has no structural rigidity at all. So it's very deceiving when it looks like you still have something in there. Also, other than every study, one of the recommendations that they made was that HECO use pre-stressed concrete, steel, and fiberglass poles for replacement of the existing wood poles to increase the mean time between failure, MTBF, of these components and to free up resources for other inspection and maintenance related tasks. Now this was like, you know, wow, I didn't think of this before, you know, but it's, I mean, anybody tells you this and it's something that, you know, both engineering and our construction crews, and especially the executives want to hear. You know, we can save money on our wood pole maintenance, then that means we have more money to free up to do other things. And, you know, all utilities don't have enough money to do everything that they want to do. Everybody's on a limited budget, so more money you have, more things you can do. So what HECO did was, because of our experience with FRP poles previously, decided to go back and take a look at FRP poles again. Because of the advances in the UV resistance, we went back and took a look and tried to see if there was any application on our system. So as I said here, the FRP feasibility study, first thing was to determine if there were any applications for FRP poles on our system. We installed some test poles for a field evaluation. And we also did a cost-benefit analysis to determine if FRP is economical. In Hawaii, due to the wide variety of environmental conditions, no single pole type would be the best fit for all situations. We have coastal conditions, we have highlands, we have, you can go within 1 mile. You could be from a mountaintop ridge down into the agricultural fields, flat land, and down into an urbanized area, just all within a mile. So we have varying terrains, very tough to pigeonhole one type of pole, one type of structure into that. Wood was the most economical for us. We also ship everything in also, so we have no readily available supply. So it's the most economical, but also very susceptible to termites, as I mentioned before. Steel has a high strength to weight ratio, but very costly, and also limited use in coastal areas. We see a lot of corrosion sometimes on our poles. You can galvanize them and paint them, but you still have to do a lot of maintenance in those coastal areas. And we also use some concrete, very high strength, but very heavy and costly. And we can't use those for any helicopter lift operations. Turn it over to Bob.
Okay. Thank you, Garrett. Can you hear me? Okay, well, before we get started, I wanted to thank Lisa Nelson. I don't know if she's in here, but Lisa, when I registered for this conference, I said, oh, it's a conference on overhead lines, and I have this handbook on overhead line construction. This is a NELA publication from 1914, and I mentioned that it would be a really good tie-in, and she just kind of caught the vision and ran with it. And so I sent her a file, as a PDF file. She then went ahead and OCR'd, indexed, and put the bookmarks along the side of it, and then incorporated that into your conference CD. So you'll have a file of this on here in a very useful format you can download onto your laptop. So I just wanted to thank Lisa for that, and just give her a round of applause. Well, it turns out that Hawaii is a really ideal environment for testing utility structures because they have just about every hazard known to a utility structure, from the highest level of UV radiation in the U.S. They're closer to the equator than the Florida Keys, for example, so highest level of UV radiation. Voracious foremost termites, as Garrett mentioned. They have, on the Big Island, they have a caustic fog, a volcanic fog, which is kind of the worst of both worlds because it's got this gritty stuff in the moist air. They have rugged mountainous terrain on all the islands, salty coastal air. Pretty much the entire state is a coastal area on all the islands. High humidity, high winds, and lightning. When HECO decided to do the FRP feasibility study, again, FRP is fiber reinforced polymer. In this case, the fibers are E-glass, electrical grade glass, and resin, which is used as the binder. It's got the lightest weight of all the pole materials of the comparable class, highest strength to weight ratio of any material, and it's easy to drill and cut in the field with existing tools. And you can cut it with a Sawzall, but you're much better off to use a diamond grit blade because it's very hard and very abrasive. It will damage a standard Sawzall blade, but these diamond grit blades are available. And then you need a carbide tipped spade bit to drill it because again, it'll chew up the bits that they use on the wood. The pole material is inert and stable under all conditions. There's no harmful chemicals that can leach into the environment, which is a very big concern in Hawaii. And the pole material has an inherent resistance to fire, and it will self-extinguish when the flame source is removed. So during their feasibility study, HECO, as Garrett mentioned, looked at some additional pole applications, and they came up with distribution poles in urbanized areas, mountainous terrains requiring helicopter lifts, and poles in backyard limited access applications. Just branch out on that and indicate that a lot of these poles are carried in by hand and set by hand. And the gentleman yesterday talked about doing backlot restoration from the guys driving in on the 4x4. This may be a possible way of saving some of that money that you're doing restoring the backyard. Poles in the areas of high termite activity, poles in highly caustic or corrosive environments, and poles in areas prone to brush fires. So the first step is pretty much everyone has mentioned on all their talks here is you have to do a feasibility study, and then the second step would be going into a field test. The success of the new product is dependent upon acceptance by both engineering and construction, and HECO did a very good job of this in getting construction, operation, and maintenance involved in the early stages, trying to get a buy-in at the lower levels. And that's pretty much crucial to introducing new material. And even though they were kind of pioneers in the early fiberglass poles, this is really a new material. This is a fourth generation material in terms of UV protection and advances in material technology. So engineering was involved early. The manufacturer's reps were involved in the first installations, and they provide on-site guidance to the construction crews and answer the crews' questions, and more importantly, listen to their questions and concerns and took them back to the factories. Then HECO did a relative cost comparison of the various pole materials, and these are HECO's numbers. The numbers are about 4 years out of date. But comparable poles were given 125,000 foot-pound moment, and the data, like I say, is about 4 years old. But the FRP pultruded poles turned out to be the smallest ground line diameter, about 30% smaller than the comparable wood poles that they replaced, approximately 1/3 the weight of the wood pole, and approximately 26% more expensive than the wood pole. The next step was to do a life cycle cost analysis, and for this particular study, they used a 50-year period. So, given the EPRI study that they estimated a 20-year life cycle for a wood pole in Hawaii, and that's actually the oldest pole I've ever seen in Hawaii was 20 years old. That was that pole that Garrett showed you with the pin in there, the 3/8-inch shell, and that was a 20-year-old pole. The FRP pole life, we used a 50-year, although the industry is now projecting an 80-year life cycle. And considering the installation costs, the FRP poles represent about 150% cost savings over the wood poles. And that's because you only have to install it once. And so there are a lot of ancillary costs associated with getting that pole into the ground. So a detailed lifestyle cycle study cost analysis should include the initial cost of the material, the cost of installation costs over the study life, and the maintenance cost over the study life. For an accurate comparison, you've got to capture all the costs of the product. That includes the initial purchase price, the cost of delivering it, the cost of storage and handling, the installation cost, the inspection and maintenance cost, and the disposal at the end of the service life. So the study results were that FRP poles were found to be cost effective and had some opportunities in the ecosystem. Many possible suppliers were evaluated, 2 of them were finally selected. The 2 suppliers were selected on the basis of the criteria shown here: knowledgeable engineering and support staff, local representation in Hawaii, and the ability of the poles to use existing hardware and installation methods. So these 2 suppliers, of the 2, the first supplier is a protruded pole. These are single piece, smaller diameter, and they have a third the weight of the comparable wood pole. These are used on the 12 kV and distribution applications. Ideal for urbanized locations, areas and backlots and helicopter lifts. The second supplier is a modular filament wound pole. The modularity allows them to build a pole out of various different modules to create the required pole sizes. It's higher strength and larger sizes and primarily used on 46 and 138 kV structures. So a lot of utilities are now incorporating some design criteria right into their fiberglass pole specifications so that their planners, designers, and their field engineers can actually have some guidance as to where to put these poles and what would be good applications. And we would encourage utilities to consider doing that so that they might be put in the right applications, because if you put it in the wrong applications, we're not out to replace every wood pole with a fiberglass pole. That's not our goal at all, and it really doesn't do a good service to it. But there are a lot of places where wood won't work, and Hawaii happens to be one of them just due to the termites. So some of the things that we put into fiberglass pole specs are where fiberglass poles might be a good solution, or where the life expectancy of the new pole is less than 20 years. If you're replacing a wood pole and it's been in service less than 20 years, it might be time to consider changing materials. If you have a complex equipment pole set in concrete, pole with high future change-out cost, for example, where the pole and step material costs less than 25% of the total pole replacement cost, then you might want to consider it. If you've got a complex, busy pole with a transformer, several cross arms, a riser, joint users on there, that's not one you want to change out very often. So you want something with a little bit longer service life. Again, as we mentioned before, inaccessible areas or locations requiring the pole to be set by hand or helicopter. Poles in tight quarters must be changed out hot. One of the things about the fiberglass poles is they have the same VIL as hot sticks, and so they're non-conductive. They're safer. Safety is always a concern. And poles in urban areas where some additional ground line clearance might buy you out of a situation where you need additional sidewalk clearance for wheelchair access or ADA compliance. So in conclusion, the acceptance of the FRP poles includes typically a feasibility study, getting construction involved at the beginning, doing a cost-benefit analysis, and selection of suppliers that have good product support. FRP poles will allow HECO to optimize the use of the right material for the right application. And by optimizing the use of the correct material, HECO effectively manages cost per its pole installation. Thank you. Other questions?
Any questions? Go ahead. Go ahead.
What's a good example of a wrong application?
Putting a fiberglass pole in place of something that has been working well. I mean, you're taking a pole, a wood pole out that's been there for 60 years. I put a wood pole back, and I know that's heresy, but you know, you need to have something that covers premium cost. And again, as we said, in Hawaii, to deliver the poles side by side, we're more expensive, about 26% more expensive. But if the savings, and I am a heretic in a lot of ways. I would love to tell you about all the savings in maintenance and inspection, but in a regulated utility, the crews have to go out and inspect the other components that haven't caught up to the same level of reliability. And the guys with polymer insulators are trying to get to 50 years, so they still have to go out and do it. When all of the different components of the total structure become maintenance free for 50 years, then it's going to level the playing field, and then we'll start seeing some more advantages. But if you've got some material that's working really well, as Garrett said, you don't fix it if it ain't broke. Yes, sir.
How about lightning?
You're not a plant, right? Okay. Southern California Edison's got a line up in the Mojave Desert, and it's 7 lines on a ridge, and they were all wood poles. And I think in the space of 5 years, each of the poles have been replaced 2 or 3 times. Each one of them. It's just a big lightning edge. And they were wood poles. And so they put in some fiberglass poles, and they also put in fiberglass cross arms. And as far as I know, they've not had a lightning strike there, and it's been about 2 years now. However, they didn't bond, didn't do any bonding, didn't do any grounding. And a couple of the angles they turned, they had guys on there, and initially they didn't put insulators in the guys. And that kind of actually runs the lightning rod up to the top of the pole. So when they put the insulators in there, this was right shortly after the installation. As far as I know, they've not had, Quentin may have better information, but last time I checked, they hadn't had any reports of lightning damage, put it that way. Good question. Any other questions? Thank you very much.
Thank you, gentlemen.